All right, so when it tells me which variable to solve for, okay, I typically find that variable in my equation. I underline it or circle it or something so I know that's the variable I'm trying to get on its own. So that's the variable you're not going to move. You're moving everything else away from it, okay? So A is already separate from the H, right? We have a 1/2 though, and we have a B that are still attached to my H, okay? I have 1/2. Up here it says remove fractions by multiplying by the reciprocal. What is the reciprocal of 1/2? It was even one of our examples. It's 2/1, right? So we're going to multiply both sides by 2/1. Okay, that moves it, so it's no longer here. Okay, but my other side is now 2A, and we're left with BH on the other side. If you want to like keep underlining the variable you're trying to get by itself, like each step, so it sticks out to you, go for it. So now I have a B still attached to my H. What's wrong, Savannah? What's wrong? So to get rid of the fraction of 1/2, remember fractions are dividing, right? Technically that's 1 divided by 2. So to undo that, we multiplied by 2, right, on both sides to get rid of the fraction. So there is no more fraction with BH. I've moved it to the other side by multiplying by 2. So now my other side is 2 times A. So how do we get rid of my B? How is it attached to my H right now? Is it B times H, B divided by H, B plus H, or B minus H right now? Right now it's B times H. It's not there, but I mean, if you wanted to, this is multiplication. So how do we take away multiplication? We divide it. So we're going to divide both sides by B. So we have 2A divided by B equals H. And that's our answer. So it's not going to be a number today. Okay, we're rearranging the equation. So everything that was in the equation is still there. We're just moving things to the other side. We're going to do more. That's only the first one. Yes?
I don't understand like the first part.
How we got rid of the 1/2?
Yeah.
Okay, so we multiplied both sides by 2 is what we did up here. Okay, so this is technically 1 divided by 2, right? To get rid of that, we're going to multiply by 2. If I do it to one side, I have to do it to the other side. I have to multiply it over here. So if I do 2 times 1/2, that gives me 2/2, right? Which is 1. So that's why we do it, because we're trying to get rid of it. We don't want it on that side anymore. But if I do it to 1/2 of my equation, I got to do it to the other half of my equation. So I have to multiply the other side by 2 also.
So if it was a different number, would we still do that?
Yes, like number 11. So our next one has 1/3, right? So what do you think we're going to multiply in that one? 3. Yep. Technically, it's 3/1. Yeah, to get rid of it. Yeah, number 11, we're solving for B, right? We're trying to get B by itself, so that's right here. So it's almost like the one we just did, a little bit. Now we have V equals 1/3 BH. This is a volume formula. We're solving for the base of whatever this shape is. Okay, yeah. Good, so we're going to, multiply by 3 on both sides. That gets rid of the fraction. It has moved it over. 3 times 1/3 is 1. So we're not going to write 1BH. Does that make sense? Technically, that is what's there, but we don't write the 1. My other side is 3V. We're left with BH on this side. And then, so we want B by itself. So just like last time, we're going to divide by the H. It is being multiplied right now, yeah. So to get rid of it, we're going to divide. So we're left with B is by itself, and it equals 3V divided by H. So all of the letters that were there to begin with, they're all going to still be in your answer. Oh, it doesn't matter. You could do either way. If you have 3V over H equals B, that's the same thing. All right. So right now, it is being divided by 2. Bless you. You okay? All right, number 12 wants me to get M by itself. So M is right here for my visual friends, if you want to indicate where it is. So looking at that, I have a V squared being multiplied to M, right? And I have a 2 being divided by M, or divided into M. Do we see that? So we have to move the V squared and we have to move the 2. Those are our 2 pieces we're trying to get rid of, okay? The 2 is being divided right now. So what's the opposite of that? Multiply. So we're going to multiply both sides by 2. That moves it away from this side and moves it to the other side. We have 2K equals MV squared.
I feel like there needs to be like more to it.
Like you're trying to do more than you need to?
Yeah, but I feel like the things unsolved.
Oh, no. It's because there's no numbers. No. So I have MV squared, right? So what am I going to do with V squared? We're going to divide it. Divide by V squared. Divide by V squared. So now we have M equals 2K divided by V squared. So those top 3 were very similar in steps. Do we have questions about any of those before it changes up a little bit? Which is the math, technically. The rearranging is the math that you're doing. Yeah. Do you think you can attempt number 13?
No,
Not yet. If you're not ready to go by yourself yet, that's fine. I can stay with you.
I'll stay in the shallow end.
We can't. There's no numbers, guys. We can't try to.
Yes, you can. What are you trying to get by itself in number 13? What does it say? We're trying to get B by itself. Okay? The B is right here. So what is the thing? Before you even start the problem, think to yourself, what's attached to the B? What am I going to have to move? So what is attached to it? There's a C. How is the C attached? Addition. So I'm going to have to subtract it eventually, right? What else is attached to my B? There's a D. How is D attached to it? It's being divided, so I'm going to have to multiply it to move it, right? So you already have a game plan. I'm going to have to multiply D. I'm going to have to subtract C. Okay, you know what you're going to have to do to move things over. Okay, which one do we do first?
No, subtraction. No, multiply.
We need to multiply the D. Get rid of the fraction first. Get rid of the fraction first. But if it's all being divided by D, I need to move that piece over. We good? Yes? So how am I moving the D? We just talked about it. We're multiplying. You multiply by D on both sides. So it's out of the way. D times A is just D. You can do DA or AD. Whatever your heart desires, friends. It doesn't matter. Okay? Mathematically, we keep things alphabetical order. DA is the same thing as AD. Okay. We still have B plus C over here. Yeah. So yeah, now it's time to move the C, and we already decided in our game plan we're going to have to subtract it. So subtract it to the other side. AD minus C. This is what's kind of nice about letters. You can't combine them, right? So it's just AD minus C. It's literally just that. Equals B. And now we're all done. Someone's music or something is really loud. Just turn it down for me. We good? So that one had the multiplying by the denominator, like our other ones did. This time we subtracted something over instead of divided something over. All right, our next two are a little bit different. There's no more fractions, right? 14 and 15, there's no fractions. So we're not going to have to deal with any denominators here. Okay, really 14 through 18, there's no more fractions to deal with. Okay. All right, 14, what are we trying to get by itself? The W. So I'm going to mark that in my problem. There's my W. Okay. All right, game plan. What is attached to my W? There is a 2. How is the 2 attached? So we are going to eventually have to do what to get rid of it? We're going to eventually have to divide by 2 at some point. Okay. What else is attached to W? There's a 2L. How is the 2L attached to it? Addition. So eventually I'm going to have to do what to get rid of it? Subtract it. Okay. See how taking a second and getting a game plan? Okay. You know what you're going to have to do. Now let's do it. Which one are we going to do first? Are we going to divide by 2 or subtract 2L first?
No, subtract it.
This time we're going to subtract first. We're going to move the loose piece over. We did that yesterday also. Okay. Move the loose piece to the other side. So we're going to move all of 2L over here. So 2L minus 2L is 0. We've moved it. P minus 2L, again, because they're just letters, it just stays P minus 2L. And we're equal to 2W. Yep, now, let me indicate my W. We have the 2. Our game plan, we already decided we're going to have to divide by 2. When we divide by 2, we divide each piece by it. Like that. Divide every single piece, every single term by 2. So here it's gone. P divided by 2. Well, that just stays P divided by 2. How about 2L divided by 2? That becomes just minus L, right? And then we're equal to W. So all the things we're doing today, we have done before just with actual numbers. Usually we only have 1 letter or 2 letters to worry about. Okay, but all the steps we're doing today, we have done before. You just organized a little bit different. Yes, I want you to try number 15. Okay, AX plus BY. Oh, what form of line is that? Ooh, good job. Standard form. Beautiful. AX plus BY equals C. It says solve for Y. You can do this. So I want you to get the Y by itself. Remember, the only way to fail this class is to not even try. Pencil to paper. Try something. Okay? Solve for Y. All right, so there are 2 ways you can write the answer today. Welcome, Antonio, to Math Without Numbers.
Why didn't you just tell me multiple letters?
Yep, Math Without Numbers today.
So
So the first thing you should do here is we should subtract AX to the other side. So you have C minus AX. We're trying to get the Y by itself. Then we're going to divide everything by b. So we divide c by b. We divide negative ax divided by b. Nothing simplifies. You can keep it looking as two different fractions, or you can write it as one fraction below. Technically, both are correct. Okay. The difference from the one before is I was able to simplify 2 divided by 2. Right, Dion? That happened in 14. That didn't happen in 15. There was no other b to simplify with, so the b's would just stay there. All right? Yes, no, maybe? I saw good things. I did see good things. The next one, it is slope-intercept form. Yes, it is slope-intercept form of a line. All right, so we have y equals mx plus b. It wants me to get x by itself. Get x by itself. All right, so what is attached to my x? Let's get game plan. What is attached to my x? There's an m. What else? And there is a b. How is m being attached right now? So how are we going to move it? We're going to divide it eventually. How is b attached right now? It's being added, so how am I going to move it? We're going to have to subtract. So we have a game plan. We're going to eventually divide m and subtract b, right? So we have game plan. What are we doing first? Subtract the b first. This is where the opposite of PEMDAS comes to come in. Okay, so we move the loose number over first, and then we divide by what's left. So we're going to subtract b to the other side. And this is where not having numbers is kind of nice, because y minus b is just y minus b. It's still equal to mx. In our game plan, what are we doing with our m? Divide by m, and we have to divide each piece by it. Does y over m or b over m simplify in any way? No. So we can leave it the way it is. We can say x equals, we can leave them as two separate fractions if you want to. Or you can say y minus b divided by m. Both are correct. So the point of having two separate fractions is that one of them might simplify, like they did with our purple problem in number 14. Okay? It doesn't always happen, and if it doesn't, then it stays like 15 or 16, where the fractions just stay there. Are we getting a little bit more comfortable? A little bit? A little bit? Okay. Okay. All right. A equals P plus PRT. What variable does it want to get by itself? The t. All right, it wants the t by itself. I see the t over here. All right, game plan. What's attached to it? There's just a p and there's a pr. Good. How is just the p by itself attached? Addition, so we're going to have to subtract it. How is the pr attached? Multiply, so how are we going to move it? We're going to have to divide, okay? Always a good idea to take a second and come up with that game plan first. All right, what are we moving? The p by itself. Good. We're going to subtract the p to the other side. What is a minus p? A minus p. Look at that. PRT. All right, we want this t by itself. We said the PR was attached how? So how are we going to get rid of it? Divide. Remember, divide each piece by the PR. 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 Does A over PR simplify in any way? No. A over PR is what it is. How about, and there's a minus, how about P over PR? Yes, the P's simplify, right? So what's left on top though? Because we have an R on the bottom, but something has to be above it. It's a 1. And we are equal to t. So t is still there. We're equal to t. What are we confused? Who said it? Okay, so p divided by p, okay, they cancel, but we can't have like an empty numerator, right? P divided by p is 1. So that's where 1 came from. And then r is still just left on the bottom. We didn't mess with the r. All right. All right, what is new in 18 that we haven't dealt with yet? There's parentheses going on, right? Now, you are not going to distribute. Because to distribute means to add more, right? It makes it more complicated. I want to take things away. We talked about this yesterday. What is distribution? It's multiplication. So how do we get rid of that? We're going to divide, okay? We want a by itself. There it is. So we do need to get rid of that n, and we're going to do it by dividing by n. Does that make sense? Because now, look, it's just gone. If you were to distribute, you're adding more n's to it, and there's in our way, and that's not going to help me. Okay, so divide n to the other side. That's an s. So we have s over n equals a plus 1. It's an s, yeah, it's a cursive s. So what is our last step this time? Subtract 1. And again, Sn minus 1 is just S over n minus 1. Like that. Okay, so the new part with 18 was that we had distribution show up. But again, we talked yesterday, distribution is multiplying. So to get rid of that, we divide. Two more. What do you think 19 is a real equation for? Like in real life? Temperature. Yeah, this is going in between Celsius and Fahrenheit to convert between the two. Yeah, this is a real formula. So if someone gave you the degrees in Celsius, what we're about to do right now is we're about to solve for it in Fahrenheit. Bless you. Okay, so it wants me to get F by itself. F is in here in my parentheses. So let's use what we just did, right? 5 over 9 is a distribution. We don't want that, do we? I want to get rid of 5 over 9. What did we say to do with fractions? We haven't done it since the beginning. Flip it. We're going to flip it, right? So instead of 5 over 9, we're going to multiply by 9 over 5. And we're going to do it to both sides. So we have 9 over 5 C. It just goes in front of it. Equals F minus 32. What's wrong? My giant C. Here, I'll make my F bigger so it's. Is that better? So it's 9 over 5C equals F minus 32. You could also technically you could say 9c over 5. If you wanted to put c into the fraction, technically that is the same thing. Okay, both are the same thing. I like keeping things simple. No matter how you write it, what's our last step? Add what? Add 32. So 9/5 C plus 32, again, what's nice to not have numbers is that's just what it is. 9/5 times C plus 32 equals F. The end. So if someone gave you the degree outside in Celsius, you could use that equation, you could plug it in and solve for Fahrenheit. You could. I will help guide you. How about that?
Why don't you just like don't look at the board?
All right, so we have A equals 1/2 H times B1 plus B2. What variable does it want by itself? B1. So that's right here in my parentheses. It's the first B. Game plan. We're going to have to eventually subtract B2, right? That's what kind of sticks out in my head. And we're going to have to do what else? We'll have to divide by H. How are we going to move the 1/2? We're going to flip it and multiply. Okay? So, what are we going to do first? Let's get rid of the fraction first. That's always a nice game plan. If you can, get rid of your fractions. So how am I going to get rid of 1/2? Multiply everything by dose. By 2. It gets rid of it over here. We now have 2A equals H times B1 plus B2. All right, moving the H or moving the B2? How am I going to move the H? There you go. Divide by H. 2A divide by H equals B1 plus B2. All right, it's almost by itself. Last step. Subtract B2. So we have 2A over H minus B2 equals B1. Yes.
I'm confused. Did you do like the different way that you showed in number 18? Not 18, 19? Like when you solved it?
The fraction part?
Yeah.
So 1/2 flipped is 2 over 1.
Well, okay, no, like how you get the 2.
Oh, because it was just 2. So on the other one, it was 9/5. It was still a denominator and a numerator. Like instead of putting 2 over 1A, I just said 2A because that is just the number 2.
But can we do it that way?
Yes. Yeah. You could. Yes, sir. Number 12 on the homework. I don't know. I guess you're going to have to figure that out later. Is it going to be the same? Is it going to be different? I don't know. It's almost the same, right? But it's asking for B2 instead of B1. So it might be. It might be. It's nice having adding, right? Because that kind of goes back and forth. So it might end up being the same thing. Almost. All right, so you got 12 more problems tonight. Okay, what are you going to do with pi?
I don't know. I don't know why.
You mean number 8 and number 4? Well, number 4, you're getting pi by itself. So you're not going to touch pi on number 4. Number 8, okay, how is pi connected to h? It's being multiplied. So how are you going to get rid of it? Just divide by pi and just leave it alone. Yeah.